we're going to actually integrate sec x. We're not going to use a standard formula or anything. We're actually going to go from the start, and I'm going to teach you how to actually do it using some manipulation of trig identities. So the first thing now, okay, so let me just write it down. So I'm trying to integrate sec x with respect to dx. If you saw in formula booklets from Edexcel, AQA, OCR, MEI, they actually give you this. And what they give you is that sec x, when you integrate it, dx is going to give you ln sec x plus tan x plus c, right? They're going to probably give you this because it's pretty hard to manipulate and use the ideas from trig identities to get this answer. But I'm going to teach you actually how to do it from the start. So the way you actually want to do it, there's a trick you have to kind of use. This whole thing relies on you using U substitution. If you have learned that in A levels, it's just a way of integrating, and I'll probably make a video on this soon because it's a pretty useful technique. But another thing that you need to know is this kind of identity. I'm not sure whether they taught you this in school. They most likely didn't, because you don't need to know how to derive it, but this is the identity I'm talking about. So sec x is equal to sec x times sec x plus tan x divided by sec x plus tan x, right? How did this come out? Not very sure about this, but it's just an identity people use trying to integrate such functions, and it's a very useful one, and you'll see why. So when we've got this, we can separate the numerator, so it'll give us this. So integral of sec x gives you the integral of sec squared x plus sec x tan x over sec x plus tan x. So you see what I did there? I just expanded the bracket by multiplying these two values out for respect to dx. Now we're going to use a U substitution. So how am I going to do this? I'm going to say U is equal to sec x plus tan x, right? And where I got this from, it's from this denominator there. So we're going to use that U substitution. Now we're going to use du by dx, which will give us sec x tan x plus sec squared x. So you can just use this and differentiate respect to dx to give you this answer. The way it works, you just differentiate both of these individually, and you know that tan x gives you this, sec x will give you this. Again, in the formula booklet, I'm pretty sure they give you the derivative of sec x, but you can obviously do yourself, okay? I could, you know what, I'll show you how to do it right now. So pretend we have sec x, right? We're trying to derive it, so derive the differential of it. So we're going to have sec x is equal to 1 over cos x. We're going to put this 1 over cos x up, so I'm going to say cos x to the power minus 1. Now, if you ever learned the chain rule, what this does, you bring down the power and you put the derivative outside as well. So I'm going to have minus 1. So what's the derivative of cos x? Well, let's use this table. sc minus s minus c sc. On the way down, it's when you differentiate it, so dy by dx, and up you go integrate. So let's see over here. So you have cos x, right? So where's that? Let's see, cos x here. Okay, so when I derive it, I'm going to get minus sine x. So I'm going to have minus 1, also minus sine x, and then I'm going to remain this bracket inside. So I'm going to have cos x. And I'm going to remove this power by minus 1, so minus 2. So that's going to equal sine x cos x to the power minus 2. And then you can say that's sine x over cos squared x. Now that is equal to sine x over cos x times 1 over cos x. And this is obviously tan x, and this is sec x. Hence we've got this sec x tan x plus the derivative of tan x, which is obviously sec squared x. Right, so let me just remove all of this. 1 second. Whoops, 1 sec. Delete. Okay, after we've done this, we can see that this u substitution, when we derive it, it matches our top part, doesn't it? So you've got sec tan x over here, and you've got sec tan x over here. You've got sec squared x and sec squared x. Hence, we can simplify the integral, and we can cross this out because we're going to rearrange basically for dx. So when I 1 over sec x tan x plus sec squared x dx, du is equal to dx. We're going to multiply the integral out, and that's going to do this. So sec x tan x plus sec squared x divided by our denominator, which was sec x tan x plus sec squared x, times it by our times it by our thing over here, this 1 over sec x tan x plus sec squared x. This thing cancels, is going to integrate 1 over u du, respect to du, and so that's going to give you ln u plus c, right? Ln u plus c. And now we can actually sub back in the u, and it will become the integral of sec x dx will give you ln sec x plus tan x plus c. And there we go. That's the answer to this equation. Or not equation, the integral. Okay. I said in the previous video I'm gonna probably go through some things, how you arrive at this expression over here. I'll probably go through that in another video. It's gonna be long. It's gonna be very algebraic, I think. But yeah, that's how you actually integrate sec x. Okay. Thank you, and